Okay, good afternoon, everyone. Good afternoon. So this session is about Rakuten Ichiba, starting from overall introduction of Rakuten Ichiba, and also we will touch about our frame and also Rakuten catalog platform, presented by 7 persons. First person, I guess, is Mr. Kobayashi Yusuke-san, and it goes to Chejun-san, Jin Nagumo-san, Suguru Suzuki-san, Daniel, Mr. Daniel, Ryuma-san, and Keiji Shinobu-san. So please go ahead.
Good morning. Thanks for attending the sessions. I'm Yusuke Kobayashi. I'm working for Ichiba. And you know, Ichiba, Rakuten Ichiba has turned, I will provide in Japan Ichiba and global Ichiba and cross-border trading. And there are billions of items, catalog data, the ton of accesses from users to the web and mobile native apps. And today's here's leaders will explain the detailed topics especially 4 topics from each areas. One is front-end and mobile native apps and cache architecture, and last is catalog data with collaborating with RIT. So firstly, we are talking about our framework. Daniel, please.
Hello everyone, my name is Daniel. I work in Japan Ichiba Mall in the front-end team of the technology group. And apart from developing in JavaScript front-end, my objective here is to try and improve all this development process and quality of the code of Japan Ichiba. And that's why I'm talking about the R framework, which is a solution we are developing here. But don't worry, I won't talk a lot of technology, because this is 2016. We have already too many JavaScript frameworks, technologies. Anyways, I cannot assure that no new framework for JavaScript will be created today, somewhere. So, before this, I have a question for developers, engineers, especially front-end ones. How many people is using new technologies, new frameworks here? You can raise your hand if you want. Okay. New, I don't know, 2-3 years ago, from Angular, React, this kind. So, who's using still jQuery? Let's assume jQuery is not new. And who's using something that you will call a legacy system? Okay, thank you. So, basically, why I'm asking this, because I don't want to talk about the technology, I want to talk about renewing a legacy system. So, this is why we are creating this. So, if you ask any of the engineers, we will say, okay, let's do it again, we can do it, right? We have some database system with an API, controllers, and all the front end using this, right? So we can just update the controllers and create the front end using a new technology, right? Yeah, that's maybe the optimal way for an engineer, but let's assume it has a big impact, especially on big companies like this, with a lot of teams, and it takes time. So what are we doing? Step by step, with less impact and compatible with what we are using right now. So we have this phase 1, we have phase 2, and the profits, right? So phase 1 is what the R framework is trying to do. Setting a standard code, which we will use to take us next step to the new technologies. So, how are we doing this? If you take a look to the Ichiba page, you can see there's a lot of parts. And if you represent graphically how many code are required for each of these parts, you can say something like this. If you take a look inside the code, you can see most of the code is repeated. And this is basically what I call the shared code. So we have here just the basic concept of a library, right? So the R framework is providing this and other objectives we are trying to take care of. So, well, I said I won't going to talk about technology, but I want to introduce it a bit. So this is what I like to call the R family, which is basically composed on 4 components. The first one is the R modules one, which is, it drinks from things like CommonJS, Require.js, the Node, the module system, which is basically the definition for all the other modules. Then we have the basic library, like providing all the common functions that are used in all the systems, which, well, common functions you can see in all projects. Then we will have this RUI, as its name says, it will provide componentization, widgets that are used. And the RAPI is just a collection of wrappers, which is actually one of the most useful ones, because when you have a big company, you have APIs developed by a lot of systems, a lot of teams, with maybe providing some data for the same components, for the same objects, but with different responses, okay? Different way of returning the data. So this just kind of standardized everything. And that's all, because this is not about the technology, this is about the workflow. How are you doing this? And it's more like a standardization. I want to keep you in mind this standardization thing. And trying to update a legacy system before going with the next technology. So, I think we have no time, maybe? So, okay. If there's any question, you can do it now, or you can just find me later.
Are you moving from the entire Angular?
No, we are not doing it Angular, probably. We are thinking more about React. So if there's no other questions, okay. Another question.
How is the wrapper design? Is it like a JavaScript wrapper?
About the APIs?
Yes.
Yeah, they're just a library, a set of functions that we can use from the, the front-end engineers are using these APIs just like calling functions, JavaScript functions. We return a promise, which will be resolved to all the data in a standard way. We are not providing the data as a raw object, but providing objects itself with getters.
So that wrapper is mapped to the component, like that gives exact same data that component required, or like that wrapper gives all the data?
It usually gives the data provided by the API. For example, if we have one object, well, it's very shown in Ichiba, like an item, right? An item has a price, name. Sometimes this API, most APIs will return the common data, like that, the name, price, image, whatever. Some other APIs will return maybe sometimes some discount. So it depends on the API you use. You will have always the common data, but the thing is that each API will return the data with a different name. Probably, I don't know, item underscore name at the item name. So yeah, it's a way of standardize everything. So even if the API returns different data, all the code used from the JavaScript side will be the same. So I think it's turn off. Jim?
Thank you, Daniel. Hi, good afternoon. My name is Jin. I'm the lead engineer of Ichiba's app. Today I'm going to talk about the reconstruction of the Mina user app. So here's the agenda. Firstly, let me briefly introduce the Rakuten Ichiba's app, and after that, I will talk about what kind of problems we have and what kind of strategy and actions we take to resolve problem. And lastly, let me summarize the lesson we learned. So about the Rakuten Ichiba's app. Well, this app is the first app that will come to the top of the list when you do a search for the keyword Rakuten in the App Store. So to some extent, it could be considered as the face of the entire Rakuten group on the iOS platform. Currently, this app has two parts. The first one is the main bundle app, which provides the basic Rakuten Ichiba functions like search, put to bookmark, and of course purchase. And for users who are running their device on iOS 10 and above, we also provide an iMessage extension that let user search and share their favorite items right inside the iMessage app. So no need to say this is one of the most important apps in the shopping category in Japan's e-commerce market, with tens of millions of active users every day. However, not surprisingly, as many other companies that have been providing internet service for such a long time in this industry, we have also been facing the problems that got caused by the legacies. Firstly, the code base, or in the high level of architecture, the code base is pretty ill-formed and just expanded without any predefined strategy. And there's no unified coding styles inside the code base, so each developer is just doing things at their own preference. And to be honest, a number of them are pretty bad. So when you taught this, you don't know when you got bombed by these mines. So with that in mind, it's not hard to imagine that just things becomes more and more fragile and difficult for you to add new features to a code base. Every time we try to insert or remove a single piece of code, it will fall down. So since it's a million-user app, any single failure, no matter how tiny it is, will bring us huge negative impact, not only to the end user, our customers, but also to our company. So the last problem is not technical, but is the one that we cannot ignore. So the thing is, since the app is broken, and once it breaks, we got a lot of negative impacts. So without these people getting involved in this product, it just become like, don't touch this, don't touch that. We don't want this, we don't want that. Just keep as it is. With this kind of mindset sticks in our head, we cannot do any more innovation that could pleasant our customer or thrive our company in the long term. So how do we write this wrong? Well, different with the R framework approach that Daniel talked just now, we, after thoughtful discussion and thought, we decided to rewrite it from scratch. We also have considered what happens if we go with refactoring, but soon find there are limitations. The first one is, since you want to go with refactoring, you have to control the scope of the code and logic changes, or else it will be rewrite. So we have to decode the legacy, which will cost us much more time than just redesign everything from scratch based on the I/O. And the second thing is, there are some wrongly chosen technologies still sitting at the bottom of architecture. So no matter how hard we try, we still have to play with the bad design interface, which prevent us from writing really good code. And third thing is, the code base hasn't been maintained for a long time. So currently it left us very, very little space for us to find a safe starting point to do a refactor. So as a conclusion, we just think the code base is just too fragile to survive refactoring, so we just keep it and reconstruct everything and get everything done correctly this time. To start, we carefully redesigned the whole architecture. At the bottom, we created a data model and the basic business logic tied to split data models. And after that, we created local and remote data providers that map to each of our remote API. And later, we created data source containing business logics for specific UIs. And on top of everything comes the UI parts. The good thing of this rewrite is we create all the reusable code as a framework, which we named RakutenTechConf2016. With this framework, it makes the test of our code could not be more easier than ever before, but also makes the development on other Apple platforms like Apple Watch or Apple TV possible, and it could be done very fastly. So after we design, we have to let the developers, especially for the newcomers, be familiar with new structure, so they don't put their code in the wrong place. What I did is just create a very detailed coding architecture documentation to explain why and how you like our code to be and what should you do in the actual implementation. Besides the overall architecture, for some specific, very specific topics, we also need a unified coding style to prevent bad code. Well, in this industry, well, you may have known that there are tons of ways or algorithms to achieve the same result with the same input. But there does exist some best practices for some specific topics, especially when the code is highly dependent on a specific SDK like iOS. So what we're doing is when we have some new topics, we just bring that up and discuss inside team and put it into the coding tutorials like this, so everybody just stay on the same page. And this is agreed on. This is all agreed by all of us, so nobody will have complaint about it. Another important process for enhanced code quality is code review. Well, honestly, I've seen some people doing it wrong by just doing fault finding, like a typo. They reject your code if a typo in your variable name or even a comment, or just reject your code when your curly braces is not in the right position. Well, I don't care about that. In my point of view, the only important thing in code review is just decrease the code dependency on a specific developer. Currently, I'm reviewing almost 95% of our code, and sometimes other members help me with that as well. The only criteria I have towards code review is just think, if you think you are fully capable of debugging this code alone, then you can mark it as approved. The reason is that if you can't understand the logic, you cannot debug it. And if you can understand the logic, it's easier for you to spot what's going wrong. So this purpose code review. So this code review is not a place to criticizing or blaming people, but in the opposite, it's a place, it's a very important place, a process for us to learn from each other. So one last improvement we made is to change the assignment style. Previously, we just assign each developer to do each feature. So developer A, you do this, developer B, you do this. But however, gradually it turned out, we just found that the developers are just have to write a duplicate the same code exactly as the others are doing. So in this case, they have a much more distractions by jumping from different layers, which harm the code quality. So now we just do a horizontal assignment style like this, showing the right picture, with one developer only implement the field that he's most good at. So with this style, it boosts our productivity and speed very significantly, and it leaves the developers space for them to polish their code. And thanks for the cross-code review system I talked before, you don't need to worry about the skills of developer only are limited to a specific field. That won't happen because we review each other's code. So to summarize, well, the most thing I want to say is to just refactor your code early and refactor code often. Treat the code base as patient. Don't leave it to die. Don't leave it to die. Just refactor it once you find something there apparently going wrong there. And you have to continuously refactor your code, including backbone, to make sure your code base conforms to the latest and best practices in this modern software industry. And we also need consistent guidelines and tutorials to make the code guidelines consistent. And you need to be right to assign the right person to do the right thing, which we say "dik-sai-dik-sho" in Japanese. And last thing is just to make your code more stateless and make your code more testable. That's all from me. Thank you very much. Let me hand over to Juan.
Good afternoon, everyone. My name is Kajun Huang. Most of my friends call me Andy, so feel free to call me Andy. You can find me on Twitter and GitHub. If you are watching like Python Redis client or Python Redis cluster client, probably seen me this ID before, and also in the Redis mailing list. So we are talking about Redis cluster in Ichiba. So let's start. So right now, Redis cluster supports some of our most important services: Rakuten Global Market, Rakuten Taiwan, and SPU, which is the campaign platform right now in Rakuten Japan. Why we choose Redis cluster? Firstly, Redis is really great. The performance of Redis is really good, and And then, if you like Redis and you're using production, then sooner or later you'll find out that one single instance will not be enough. So you need a distributed Redis instance services. And Redis cluster has been production ready since March of 2015. And it's becoming better and better with the help from the communities. And also it's relatively easy to provision and manage comparing to the existing solutions. So this is how a Redis cluster looks like. This is the simplest setup. So at least you need 3 masters, and each master will have his slave, and master will replicate the data to the slaves. And you also have slots for keys. So basically slots are just abstraction for managing the keys. You do a simple CRC16 hash function, and then you can get a slot for the specific key, and Redis cluster is able to figure out which slots in which node, and then the key will be sent to the node. So also Redis cluster uses gossip protocol to understand the states of each other. So for example, slave B, the master B probably can, during the running, probably find out that, okay, C is down and mark C is down, blah, blah, blah. So it's a distributed system with a gossip protocol. So with the design, you have some limitation of the Redis cluster. So firstly, it only supports up to 1,000 nodes, which means you won't be able to have a really, really large cluster. And secondly is, if the majority of the cluster cannot be reached, you cannot have a functional cluster. And this is very simple to explain. You need majority of masters alive to make some important decisions. And also you must have one slave for each master. This is a typo. You at least have slaves for each master, but the number of the slaves can, well, you won't, it's normally not a good idea to have 4 slaves to a master. The reason why you need to have slaves is because you want the slave to be covered the master if the master goes down. And if the master goes down, you will lose some slots on that master. Although you can configure that the slots can be, you are not able to access the slots, but still fine. It's configurable, but generally it's not a good configuration in my opinion. And during the small window, which means during the failover process, you can lose some rights to the cluster. So, and then we come to why we choose Redis cluster in Rakuten Ichiba. Firstly is application were using Redis, so it will be difficult for applications to move to other solutions like memory cache lead. And we do not want to maintain Twin Proxy and Sentinel Redis, to be honest. Because I went to RedisConf this year, I talked to some companies like Pinterest and I think Lyft. They were using Twin Proxy and Sentinel Redis, and most of the time they are talking about maintaining Twin Proxy instead of maintaining Redis. So I don't think this is a good idea. And we mainly use it for cache, so we can afford to lose some rights, so we don't really care what if a write to the cache is missed, and we don't really care. And it generally proves really well in the testing, especially for the failover process. There's no human involved. You don't need to be called in the middle of the night just to start a slave and then to do the manual failover. And the scaling up is relatively easy. Redis cluster provides a script that you can easily manage the cluster, so you can easily add a new node to the cluster and scale it up. And similar as scaling down. And some of our applications, important applications, are actually written in Java, and the client support in Java is relatively mature, like Redis and Redis. So this is how we configure Redis cluster. This is not a comprehensive list, but it just covers some most important parts. So currently we have 7 clusters running in production, so they are isolating clusters. Some applications have their dedicated cluster, some of them share the cluster. It really depends on the amount of traffic and the size of the payload, etc. And the application only connects to a master, so right now we don't read from slaves. We run on machines with 4 cores, 32 gigabytes memory, 1 gigabit network machine, and we don't have too much resources on. This is the machine we currently have. So we run 4 Redis instances each machine because you probably know that Redis is a single thread, most of the time single thread program. So you want to fully utilize the cores on your machine. And we basically set a 6 gigabytes memory on each Redis instance. I will talk about why we set 6 gigabytes later. We configure Redis as RRU cache, so so the policy in detail is all keys RRU. This is the policy in Redis setup. We turn off persistency because we're setting up as cache. So we turn off both AOF and RDB. We also rename some of the dangerous commands. So, for example, we rename flushdb to some commands you don't know. So to prevent people to doing stupid things. We use GlackD, GraphI, GraphNet for monitoring. So we have some dashboards to know what's going on inside our Redis servers. So what we have learned, firstly, I think probably it's the experience for most of the Redis maintainers. It's Redis service maintainers. Its bottleneck is network I/O. It's not CPU. It's not something else. It's always network I/O. Our Redis services CPU normally is under 1%. And some guys say the one time they made the CPU to 8%, they're really, really proud. So, and especially with requests with large payload, because Redis can hold up really, really high QPS. So if your size of the request payload is pretty big, then you soon will reach the limit of your network. For example, on our machine, without any TCP tune-up, we can reach to 1 million QPS with pipeline enabled. Also, the second is this I think is very important as well. Is keep this once you have a slave attached to a master, you need to keep the size of the Redis small. So that's the reason why we set up to 6 gigabytes instead of, let's say, 30 or 64 gigabytes of memory. Because during the failover or during a slave connect to the master disk process, master will sync the RDB file through the network. And if you have really large data set, it can take forever to finish the process, and you don't really want that. You really want the failover process to finish as soon as possible. And third is a new problem, so it's the client bugs, because the Redis cluster now has new protocols, and the client support, some of the languages are not really well. So, yeah, so you will encounter some very interesting bugs. And normally it's not a problem from Redis cluster, it's a problem from the clients. And it's very difficult to have persistence right now in Redis cluster because it's not that easy to recover from the RDB files. I talked to the Redis author during the RedisConf this year, and there will be a feature on the roadmap, but currently it's not implemented yet. And right now we're directly connected to the Redis, and it's pretty awesome. You can avoid extra network hop, and you don't have to copy one socket to another socket, but increase operational difficulty. So this is we are trying to solve in this quarter actually. Finally, operating Redis itself is not a happy process. So this is probably a very painful point for the operators or the administrators. So because the dynamic things happen in Redis cluster, they are making their own decisions. So it's kind of difficult to really understand what's going on inside the cluster. And the roles of the different nodes can change over time. So you want to have a visualization tool to really understand what's going on inside of the cluster. So I developed this thing based on the D3.js to visualize the topologies inside the cluster. We also wrapped the Redis tribe Ruby script, which is written by Antires to manage the cluster, who is the author of Redis. So we wrap this with UI to prevent people mistaking types of commands. So we still have a lot of future work, in my opinion. Firstly, because of the legacy code, at the time probably people didn't really understand the cluster pretty well. So they are still using very raw get and set commands. And as you may know, Redis actually is a data structure server. So you should smartly use the data structures in Redis. And then secondly we are still using hard-coding IP, and in my opinion, this is pretty bad. So in this quarter, we're also trying to using aliases or virtual IPs to replace with the hard-coded IPs. The third is unify access from one single client. I'm currently working on a project on this, and probably in the future we can share this more with the community. But generally, we want to all use to only allow all the applications in all the languages using one single client. So when there's something goes wrong inside the cluster, we can quickly debug about really goes wrong instead of going to different client implementation to find, okay, what's wrong with the PHP client, what's wrong with the Java client, what's wrong with the Python client. It's exhausting list. And fourth is we are aiming to provide Redis as a service. So we want to have automatic resource allocation. So applications engineers say, I want to use a Redis service, and bang, you have a Redis cluster instance there. So this is the future work. And also we are short of people, so we are hiring. So if you're interested in working in Redis, Redis cluster, feel free to send me the email, or you can also go to the Rakuten Korea page. Yes. And thank you. And if you have questions, you can find me. Probably we're short of time. So if you have questions, probably we can discuss later after the talk. I'll hand over to next time.
Hello everyone. In this session, I'd like to explain the Rakuten catalog platform, which is the platform to manage catalog data. So we have 3 speakers today. In my first part, I will explain why is the Rakuten catalog platform. In part 2, the KJ, data scientist from Rakuten Institute of Technology, will explain the data science technique. And in the part 3, the Suru, who is the development manager of the Rakuten catalog platform, will explain how to deliver the data. So this is my part. This is what is the Rakuten catalog platform. Actually, before going to the actual session, I'd like to explain by briefly myself. I'm responsible for the product management and also the strategy of the Rakuten catalog platform. My main background is the user experience, taxonomy, and the information architects. So a little bit different from the background with you guys have. So the first, here is the location. We are conducting the worldwide development operation for the Rakuten catalog. I myself and the school is located in Tokyo. The KJ and Anchor, who spoke in a different session, is located in Boston. So mainly development is done in Seattle and Tokyo. This is the concept of the Rakuten catalog platform. The catalog platform is one of the really important platform for the EC marketplace to connect our merchant to the customer. In the center of this chart, you can see the catalog data, which include merchant product and master specs and taxonomy and metadata. As a platform, we are also managing APIs, analytics, and tools and database. This is an example of the catalog data. And there is, in the left-hand side, there is a merchant product. As Rakuten is not retail type EC service, but more type EC service, merchant register the data in a different way. So this is a case of iPad. You can see merchants are registering the iPad with a different name and different images. So we have to unify the product information so that customer can understand these data well. And also we are also managing a taxonomy for classifying these products. Taxonomy is always used for this kind of the left-hand navigation in the search. This slide is showing how we are managing product data. So we are calling this the process as a product journey, a product data journey. We have 3 process. One is a collection, another one is a processing, the last one is delivery. Actually, the merchant submit the product data through shop management system, which is called RMS in a collection part. Then we ingest the data from the RMS. We are the process these data. Then we are utilizing these data science technique with operators to enrich and sometimes standardize this data. Then in the delivery part, this data will be delivered to the front-end application. Then finally, customer can see our data through the PC and smartphone. This is how our product data is working. This is an example of the SERP. So this is a case where the customer filtered the search by the category. So this is a case of sneakers. So the first one is sneaker, it is okay. The second one is also sneaker, but third one is actually boots. So we got complaint from customer like, カテゴリーをスニーカーで絞り込んでいるのになんでブーツが出るんだろうとまあこういうクレームが来ます。So in order to fix this situation, so we are adopting several ways of classification method. The first one is our manual classification. This is kind of a simple operator review. The second was the rule-based classification. This is like text filter. And the last one is auto classification that utilizing machine learning technique. The second example is a person navigation. This is the case. Unfortunately, in Rakuten, there is a categories where the search filter is showing up. So we got a claim. サーチをブランドとかシリーズとかサイズで絞り込みたいのにないなと。In order to fix this situation, so we are doing attribute extraction the purpose of this attribute extraction is to enrich type of search filter and expand its coverage. So we are extracting attribute values from merchant data. Attribute values means like brands, colors, size and others. Then we are utilizing these values for the person navigation. This approach will be explained by KJ in the next session.
Thank you, Rima-san. So I'm Keiji Shinzato, member of Rakuten Institute of Technology. So from my side, I'd like to briefly talk about our challenge, the automatic classification and attribute extraction. So automatic classification is a task to automatically assign a single category to the product data. The technical issue of this task is in Rakuten, so there are a bunch of categories. So right now we have about 30,000 categories. So this means that it's very difficult to find a single correct category among them. So in order to solve this problem, so we employed a hierarchical machine learning approach. So as you know, the Rakuten category has a hierarchical structure like a tree. So we try to train a model for each level, and then we try to apply the trainer model step by step. So this makes this problem more easy because we can successfully reduce the number of candidates for classification. The second challenge is attribute extraction. The attributes are kind of property for product, such as a color for t-shirts and brand for sneakers. So right now, we are only focusing on the brand extraction. So this is because the brand is very, very important attribute for our business. The difficulty of brand extraction is the ambiguity. So ambiguity of expressions that can be regarded as a brand. So for example, the expression parka have the two sense at least. The one is the writing material brand from France, and the other is a hoodie in Japanese. So we need to disambiguate the sense of parka when it occurs in the text data. So we try to solve this problem by using a dictionary-based approach. So this is an overview of our brand extraction methodology. The input for the method is the product title and their categories, and output from the method is input data with extracted brand. The first, we run the morphological analyzer on the product titles, and then extract brand from the result of analysis by using a brand dictionary. And we only extract the most left-hand side candidate matched with the entry of dictionary. So this is based on our assumption that the brand is likely to be put on the forward part of product title. So as you know, as you can see, the most important part of this task is the brand dictionary. So in order to construct the brand dictionary, so we use the heuristic rules and machine learning approach for the Rakuten product data, and then some of the results are manually judged before putting the dictionary. So this is our brand dictionary. Our brand dictionary consists of not only brand expression, but also the relevant categories. Our method employs the brand expression whose relevant category is the same with the input data. So for example, the Parker is only activated for the product data under the home and office supplies. The Parker is not activated for the data under the fashion category like women's clothing and men's clothing. So by looking at the relevant categories, we can successfully disambiguate the sense of brand expression. So right now we have the 100,000 entries. And in order to gather the candidate of brand dictionary, so we use the semi-structured data table and the listing listed shown here. So by simply applying the regular expressions, so we can easily extract the brand expression and their relevant categories. And also, we try to collect the candidate of the dictionary by using the machine learning technique. So, but as you know, before applying the machine learning technique, we need the training data shown here. So you can easily imagine that the construction of this kind of data set is very, very costly. So here we try to automatically generate training data by using the Jan code and mapping the database of Jan code and brand expression. At first, we try to fetch the Jan code by using the regular expression and then look at the brand expression corresponding to the Jan code. Then after that, we automatically annotate the brand expression in the product title. So through this processing, so we can automatically generate the training data for brand extraction. So in order to evaluate our current method, so we manually assign the brands to the 500 randomly selected product titles. The percentage of product, including the brand name within their title, is about 70%. So right now, so we achieved over 90% for precision and about 60% for recall. So these figures means that we can automatically assign a correct brand name for 92 million products in a product database.
Okay, thank you. Finally, I'm Suguru from a software developer from Rakuten Catalog platform. So before this session, Ryuma-san shared strategy of Rakuten Catalog platform. KJ shared how extract, classify, and annotate useful values from merchant products. So finally, let me share about data delivery by Rakuten Catalog platform. Before my session, please imagine if you are postman, you've been haitatsuin. If you get a request, hey, please deliver only one mail within a day. Maybe it's not difficult, too easy. But if you get a request, please deliver 1 million mail within a day, it's too difficult for you. I mean the data delivery for the small scale services and small data is not so difficult. I think it's very easy. But Rakuten has here 40,000 shops and 230 million items, 2億3000万商品. And we have to deliver those items to over 60 services. So we face very difficult situation. So I'll share how difficult to deliver those data and concept and effort data delivery on the Rakuten scale. Okay, so we think important point for the data delivery, especially e-commerce, quality, volume, and speed, and do it as fast as possible. So I'll explain the detail. First about the quality. Case by Rakuten. Quality depends on the merchant registered product information. So key point is how to get more useful information get from merchant. but unfortunately, current situation is not so good. This is a pretty panda t-shirts, and maybe, but it's not visible, unclear viewpoints. I mean, the image and item has too much information, and this is just pretty t-shirts, but category related other channel, and also this is size information. Size information has both item name and item description. Maybe you meet similar situation when you buy something at the Ichiba. It's just example. It's not this to Ichiba. Yeah, and so we are planning to restructure data registration. We are introduce register master spec key values from merchant. Now merchant register master specs only item name, description, and category IDs. So if merchant can register structured master data like this, size is color, white, and something. So if we get this structured and rich data, we can use those data to the front side, more visible item presentation. So we are planning to introduce it. And next is a volume. As I said, Rakuten Ichiba has 203,000 items, 2,300,000 products. And very important point for the volume control, prepare rich structured data for processing, before processing. So after get rich data before processing, and after that correct data to one place and do the processing. In case of the Rakuten, we are using the Hadoop to the process those data. And after that delivery to the one place, I'll explain later. If we store the data one store point, we can use to the front side more easily. Okay, so finally about the speed. As I said, Rakuten has over 60 services, and they use merchant products and taxonomy, same merchant products and taxonomy data. Meaning we have lots of destination, data okurisaki. So we should deliver those data as soon as we can, and our destination for to show fresh and meaningful values data for the merchants. So important for quick delivery is very simple. Reduce delivery time and cost by data delivery from single point and with no operation. I'll explain the sample. We already realized data delivery from single point to the front end. Product data delivered from this, and also we are managing taxonomy and facets information by the API. So sharing one illustration. Following is delivery method for the taxonomy information to show merchant product by the facet navigation like this すべてのジャンルとかですね。And this API called navigation API. Navigation API delivers category detail information like this category name and node or something. So as I said, Rakuten has a lot of services, so difficult to manage in each service if category data will be changed. So we automated category data changing information, changing operation. Sometimes we want to change the taxonomy information. Example, if we want to change the, this is a color, color showing type is currently list, but we want to show more visible information like this palette style. So we define the navigation API, change the color navigation layout list to palette. We can all UI can be changed to palette UI at the real time. Okay, so let me sum up. We are taking care of quality, volume, and speed for the data delivered by the Rakuten Catalog platform. And important point is do this cycle as faster as possible. So finally, advertisement. Now we are trying to interesting and challenging approach, but we don't have enough resources for it. So we need talent who has those special skills. So please join us and looking forward to work with you. And please see more detail from this link. Thank you very much.
Okay, thank you very much. The time is out, so we cannot have a question and answer, but I will question answer. But if you have any questions, please approach to all the presenters. Thank you very much. Next, go to